Welcome, everyone, to the Passive House Accelerator's second show of our second year. We're on episode number 54. Thanks for joining us. I'm Prudence Ferreira. I'm a senior member of the Carbon Neutral Design Group at BR Plus A Consulting Engineers, and I lead their Passive House team. And I can't see who's in the audience. I hope there are new people here. And if you're here, you're in the right place because we're a really, really fun, nerdy crew who loves sharing our knowledge with each other and our mistakes, and loves continuing to learn about passive house, zero energy, zero carbon, electrification, retrofitting, building science, all the good stuff. So it's been a rough couple of weeks for me, and I wanted to share a little bit with you guys what's going on with me. I don't usually get to do it in the breakout rooms because I always want other people to talk. But since I started my new job at BR Plus A, I've been working overtime a lot to understand how we can use passive house principles and best practices to inform how we're designing our highest energy utilization intensity buildings like labs and hospitals in a way that our industries and our institutions and our jurisdictions can actually adopt on a broad scale through ASHRAE 227. And I'm learning by taking the most cutting edge net zero labs, healthcare facilities of these typologies midstream, like right in the middle of their design. And then essentially doing gap analyses to figure out like, okay, where are they now and what would it take to get them to passive house? And then doing life cycle cost analyses side by side with operational and by carbon accounting, and presenting the results and seeing where we can get to, like if some of these teams will actually go for it, knowing that dollars are not telling the story that needs to be heard, even if we're looking at a net present value 20 or 30 years out, and seeing that decisions continue to be made on this old paradigm, these old metrics, and just wanting to rage that we're moving too slow. And at the end of each long day, I feel a mixture of utter defeat and hope. And on the days when I don't hang out with you guys, I work until I drop, and then I just get up and do it all again. And the reason why I'm sharing this is because I feel like we all are experiencing this in our own ways. We all are working our butts off in our respective areas. And as time goes on, every single new building that's not built to the best we know how becomes like a weight, a liability, a burden on our future. And in those moments of defeat, I remember that we have an entire community here and that we're all dreaming together, visioning together, and working together. And then the weight doesn't feel so heavy. And I came across this quote by Nishin Panway that I wanted to share with you all to open the show. And this is what it says. It says, "Don't keep your dreams in your eyes. They may fall as tears. Keep them in your heart so that every heartbeat may remind you to convert them into reality." So unmute yourselves for a minute because I'd like to hear all of your beautiful voices and to make a toast to the incredible brain trust we share. And even Tyga wants to toast. Here's to using our brains to manifest the dreams in our hearts.
And here's
Our
to
brains.
Cheers, Prudence.
Cheers.
Cheers.
Yeah.
Cheers.
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 Cheers. I am.
I got my coffee protein shake, man. That's my drink tonight. So we have a really great lineup this episode, and we're going to hear from not one but 3 sheroes of Passive House on a project that's utilizing prefab elements, factory installed windows, and ecological landscape design. But first, over to Zach.
All right, we're going to show a great video from a project that we heard about from at Construction Tech last night. So without further ado, I'm going to get this cracking.
HPZS is a woman architecture firm in the city of Chicago that's focused on preserving a sustainable future through 3 things: historic preservation, sustainable design, and affordable housing. And it's really at the nexus of these 3 things that placed us in a very unique space to be able to meet the challenges of a project like this.
The Unell Passive House is on track to become the first renovated FIAS project in the state.
It's not just a new construction house. It's a house that was there when the community started, but today it's being built for the future.
For us, a project like this makes perfect sense. Let's take an existing building and let's retool it for the future.
What's different about the Yanel house is that it's pursuing the Passive House certification.
A passive house is a highly insulated and airtight building.
There are lots of homes that have some green or sustainable features, but this home has an entire suite of those features that makes it meet the very rigorous criteria associated with FIA certification.
FIAS has a strict set of requirements that need to be met not only during the design process, but also tracked through the construction process, tested and verified to an extreme precision. The main design challenge was determining how to create a high-performance building while maintaining the existing structure of the house.
When you're dealing with an existing house, you have set conditions that you can't change like you would in new construction.
This was ultimately solved by overlapping certain areas of the house in insulation and by utilizing a new technology called aero barrier to help seal the entire house. Yanel is efficient because it prioritizes the envelope of the building above everything else. This helps the house retain heat in the winter while keeping it cool in the summer. Additionally, with the Yanel house, the mechanical systems were specifically selected for high performance. So when the house does need to use active heating and cooling, it's doing so in the most energy efficient way.
And the electric use of the house is offset by the introduction of solar panels on the roof.
In addition to heating and cooling, Yanel uses an ERV that brings in fresh outdoor air while continuously exhausting stale, stagnant air from inside. This creates the most healthy indoor environment possible.
A really important thing about this project is that it's a passion project of the owner.
I've always wanted to push boundaries with green buildings. My home, which is right across the alley, is a LEED Platinum Net Zero Energy home, and I wanted to try a different route with this house, and the Passive House certification seemed to make sense with some of the things that I had learned from the 10 years that I've lived in my house, so it was a perfect fit.
This project is the first of its kind in Chicago because it's the only development-driven FIAS renovation that's intended to be sold in the open market.
Buyers don't have to compromise. This property offers the highest levels of luxury and comfort without needing to sacrifice anything for the sustainability that it offers as well.
It has everything. It's designed with style, efficiency, and performance in mind.
All right, we're gonna go into breakout rooms now. Again, this is a 5-minute session, and so make sure you get a chance to have everybody say hello, and we will see you in a few.
Once upon a time, there were 3 very different little girls who grew up to be 3 very different women, but they have 3 things in common. They're brilliant, they're beautiful, and they work for me. My name is Charlie. No, I'm just kidding. Oh, I'm totally kidding. Some of you probably don't remember that show, Charlie's Angels, but I liked it. I thought it was cool. There were some pretty kick-ass women on it. Actually, these 3 women work for all of us and for the greater good. I'm honored to introduce 3 ladies that are so good that they're bad. Shannon Pendleton, Ilka Cassidy, and Angela Iraldi. They've got 5 degrees between them and I don't know, somewhere between 40 and 50 years of experience. And they all bring diverse perspectives on passive house building with the collective experience in many fields through the design and the build and verification process. So Shannon is a CPHC and sole proprietor of Sanderson Sustainable Design, and they specialize in residential and prefab design. And Shannon was a recent guest co-host on Construction Tech Tuesday, and I have a feeling she'll be there again many times. And Ilka is co-founder of Holzraum System with an extensive background in passive house engineering and architecture, as well as a guest co-host of the Passive House podcast. And Angela is a planning consultant with a degree in architecture and engineering. She's project manager at Revision Architecture, and she's a FIAS verifier. So we're going to get all of their perspectives and experiences on this FIAS Plus 2018 pre-certified project called Silver Green Passive House. Thank you, ladies, so much for joining us.
Thanks, Prudence. It's our pleasure. And I really loved your introduction today and how we're all fighting for the greater good. That resonates with me very much. Every time I see a house that isn't a passive house and is new construction, I do want to shed a little tear. But I remember you guys are here to help. So thank you to Passive House Accelerator for inviting us. We're excited to wrap up a month of women in construction and be part of such an incredible group. If you haven't been here before, please open your chat window and put your questions in the chat, because Angela and Ilka and I are sticking around after the presentation and we will answer your questions. And we're going to cover a lot of ground really fast. So it'll be like Picha Kucha, lots of slides, talking fast. So have fun. And I'm excited to be here tonight and showcase this project along with two women making history, passive house history. Let me share my screen here. And let me know if you can see it.
Looks great.
Great, thank you. So there's Angela and Ilka on the right over there. I met them both while volunteering with our Passive House community at Green Building United. And being women in construction, we like to joke around that the project team is really the family and the project is really the baby. And sometimes it is really great to be a girl and that we're kind of built for each other and we're built for this. So we need a little more soft science in our building science is what we think. So in honor of Women's History Month, I'm going to share my favorite reason to celebrate it. And then we're going to talk about how opposites attract and make building now and future planning, passive house and on-site craft, old workflows and new workflows come together. And if Stephen Conroy, our site super's on the call, thanks for lending me this picture and sharing that quote with me. I think it's fabulous. So a special thanks to everyone on our team, because step one is start with an amazing family. We have a few people that were kind of honorary family members or adjacent family members that I want to thank as well. And that's Susan, of course, the owner, who is our matriarch and gave us the opportunity to come together on this. And Evan at Zola and Kitchen and Associates and Silver Park Studios. And as Kevin Brennan said last night, behind every great project is a great owner. And that's Susan. That's a true story. So Silver Green is an all-electric, carbon smart, vapor open, custom site built and prefabricated FIAS Plus 2018 pre-certified multifamily passive house. It's a mouthful. And it's made with predominantly natural materials. It's in a town called Bernathen, PA, outside of Philadelphia, between Philly and Trenton. And we set our priorities for 2 sustainable homes to rent affordably to families now and renovate easily in 20 years for aging in place. So the architecture needs to fit in with the community and the historic district and have a big space for family gatherings, future accessible space for community events and fundraisers. And I advanced a little too quickly. Up there in the orange box is what we inherited. It's the existing building that was on site, a sentimental rental, formerly known as the Bishop King House. And on the right in orange is our oldest living residence, the natural spring, the spring house, the wetland, and a 300-year-old buttonwood tree, including the view, which is spectacular. And the history of the site where Bernathen was founded is where our site is located. And so we also inherited 4 foundation stones from the windmill that you see in the top center that fueled the original water supply. And we are at the top of our watershed. So the first thing we did, step 2, after we dug the history and got set up with the team, is we compared green building ratings and we selected passive house certification as our goal and living building as our guide, because we wanted to get the metrics right and have the most efficient, easily buildable, code compliant certification. And we also wanted to have natural materials, equity, and a lot of site features that passive house is still ramping up and getting into their certification. So we drew up a series of legacy planning strategies for the site based on the owner's priorities and designed for all seasons to get winter and summer sun and future power generation on site. And we also designed for all phases of construction and infiltration of the water. This is a Think Green landscaping drawing, which is just brilliant and incorporates the windmill foundation stones into the landscape architecture. And our goal was to really secure the exterior character for the building, so that would never have to be changed and that it would be classic and fit in. And the passive house envelope with the future renovations included, so we don't have to pull that apart later either. So we had to create our airtight, super insulated, thermal bridge free, floor, roof, and wall assemblies. And then we had to test them for accuracy. And so what you're seeing in that red line at the top is our air barrier and where it's located in our building. And the fact that we left the 2-car garage out of the passive house envelope, that everything else is in. And even though the homes are divided, I don't know if you can see my mouse, but right here, there's a wall between the two. So they're divided and they can be broken through in the future to be combined. And then on the bottom, these are our assemblies. So we've got an interior grade beam, light deck, structural insulated slab in a couple different places, under the garage and on a terrace, and the cathedral ceiling with the blown-in cellulose. So these were some of the areas we had to look at for thermal bridging to make sure we weren't going to have any moisture in our walls and that our indoor air quality would be excellent. So we also anticipated the HVAC and energy upgrades, since those things can change or be replaced within a couple decades. And we aimed to make sure that nobody had to poke any new holes when they went to replace things. And that's pretty much our strategy. So let's look at what we would repeat and what we might improve. So for our systems in the main house, I wouldn't really change a thing. We have a Mitsubishi heat pump, one upstairs, one downstairs, street level and garden level, and a Zender ERV. And when my best friend toured this with me, she said, "This is it?" She looked at this little piece of equipment that's going to go right out here outside. And she said, "That's it for that big house?" And I said, "Well, that's just one side. The other side has one too. There's 2 of them." She was impressed. And for the carriage house, we just have a similar setup, a heat pump, a Zender, and then we have a cassette in the garage to make it kind of a semi-conditioned space. And then we also have, for our electric, we're set up with electric hot pump water heaters, which are super efficient. If you haven't seen those, you want to see those. We also did do the heat pump dryers. We swapped out some of our specs for those. And we have plans for a future solar tile roof. We already have the car chargers installed. We're going to have the solar disconnect right here where the electric comes in on that same spot, and room for a future battery. And I think we're going to put a battery in now just for little loads. And let's see. So this is the exterior envelope. And this is what I really want to talk about, because we had to do the blower door 3 times to pass. So what would we repeat and what would we improve on our envelope strategy to be more airtight? At our basement, we've got these wonderful ICFs from Eudora. They're flat pack and then expandable and fillable with concrete. I would use those again. We had a happy accident where we put an insert in by mistake because it was ordered. So we used it and it allowed us to take the insulation out of our service cavity, which was awesome for future renovations, right? So that's in the drawing, but then we didn't have to put it in because we remodeled it when we got those inserts and it worked out. I love our detail for the real stone, which was a real tough thing to do because unlike brick, it's not really even along there where you want your weep holes to come out at the base. And we also allowed the mason to use this cement board and put our rain screen and our air barrier behind that. And then we had prefabricated floor separation between the rooms on the lower level. And then we had prefabricated floor decks come in and we wrapped those with our air barrier. And then here's our Holzraum wall coming in via crane and being positioned nicely on top of that floor. And then the roof trusses came in. Those were all fantastic. I would do Holzraum again in my second because they were my favorite part. They were carbon smart, vapor open, and they had those pre-installed windows. So we only had to install the windows in the basement and the big door assemblies on the first floor. And those were perfect. So the builder, even not being a passive house guy, did a great job there. On the interior, I still like the Nudura on the interior, but because it's got a little bit of a rib on it, we had to put a liquid air barrier onto the little yellow area down here where our air barrier climbs up. We had tape on it, and those little ridges, there's a little bit of air coming through there, which Angela will show you when she talks about testing and verifying in blower door tests. And let's see, what else? Oh yeah, at the ceiling. I love the Sega, and we did blown-in cellulose at the ceiling, but I would do plywood next time just because we had some sequencing issues and we had some holes that we had to chase. We were chasing leaks for a little while there. And I probably do a little bit more research on the door thresholds because we had some ADA door thresholds so that we could be accessible and age in place in the future. And some of that was a perfect install, and some of it was just like a part was broken, so we had to replace a part. But yeah, the Zola windows and doors are operating nicely and giving us the mullions and muttons we want and simulated divided lights we want, which are tough to energy model for. Something I do different, I definitely do a penetration schedule next time. This got missed, and there it is hidden under the stair after a number of operations happened inside, and we had to chase that leak too. And then we also did fireplaces, wood burning fireplaces with direct air intakes. And I would definitely do that again, but I would coordinate with the subs sooner because we had to change the unit that we wanted to get because he couldn't get it. And we also had to change some of our details because he wanted them to change. So if we had met with him earlier, those would have been in the original set, but it didn't change too much. So for designers and builders out there, if you want a prefab and you want to deliver a project, here's your midwifery delivery. What's the same and what's different? On the left is our project timeline, and COVID is in there, trust me, hard. And everything in red is kind of unexpected. So you're used to SDs, DDs, CDs, CA, which is schematic design, design development, construction documents, construction admin. Well, they all move up a phase. So you have to get all that done earlier because you're going to do shop drawing review, early package release, and a window and door order before your construction documents are done. Get ready for that. And also get ready to do a couple blower door tests. We did do a preliminary one, which was awesome, but we had to do a couple more. We're 4 months to close out. I'm super proud of our team because they took all these things that were a little bit challenging and made them awesome. So that's it for me. And without further ado, I'll see you at the happy hour to answer any questions and turn it over to Ilka Cassidy to talk about her part in the process and the Holzraum system.
Okay, I should unmute myself here. Sorry.
Ilka, do you want to share or do you want me to click for you?
No, can you click for me, please?
You bet.
Okay, so. Okay, great. Okay, thanks, Shannon. I'm also very happy to be here, and I am representing Holzraum System, and my partners Steve Hessler and David Hessler are here too, and I'm sure they will chime in later on as well. So yeah, I'm going to talk about the coordination that it takes to design a passive house kit, pretty much for a complicated custom home like this, and the opportunities that arise. So first, I just want to look really quickly at the panel assembly. So as Shannon talked about, this project is not only going to be passive house certified, but also follows principles of Living Building Challenge and wants to be sustainable and resilient for the future. So this panel, to the exterior, vapor open, airtight assembly, using only wood-based, and it only uses wood-based components. And I am happy to talk about this specific layering maybe later on, and also why it makes sense to prefabricate this in this way of layering. So as Holzraum System, we are actually not panel manufacturers, but we work with manufacturers and take the role of coordinators and translators into what will be manufactured. So for this project, we worked with Blueprint Robotics in Baltimore. And Shannon, do you want to, yeah, thanks. And in every case, as soon as prefabrication comes into play, every component has to be modeled. So a translation from design intent, in this case, we had a Revit model, into a parts-based model has to be done. So for us, that also means that there is a great potential in then using this parts-based model to coordinate with other perspectives. And we call that a SIM model, or a single integrated manufacturing model. Next slide. So we are actually able to clash, or with a coordination model like that, we're able to do clash detection with MEP and coordination with concrete, steel, roof trusses, and other prefabricated components within this kind of single high fidelity model. And because we have all the exact locations and dimensions and parts, because we know that the robots at the end will build exactly what we drew, we can actually generate steel coordination drawings like the one on the bottom there. And we can also provide back like 3D drawings to other parts or fabricators of parts that are off-site manufactured. So in this case, there was this pretty intensive groin vault that also needed to fit within those the truss layout. And then the next slide, Shannon. One back, yeah. So, and then the same model is used to actually generate the machine files, and also to generate reference panel drawings. And this is pretty much what that looks like. So, and we use the Blueprint Robotics software, which is Dietrich's, and we can output those drawings. Next slide. And here, this is at Blueprint Robotics, and you can kind of see those files in action with, on the bottom left, and then the machines just kind of fabricating rapidly, which is very impressive. And then to the right there, you can see these drawings that we kind of generated out of that model as a reference for the panels. And then, some things still have to be done by hand. And this kind of arched window was definitely pretty nerve-wracking. And we were very, very happy when that all fit in perfectly. Next slide. And then again, from the same kind of model, we actually created these panel layout drawings and installation instructions, which are for the installer on site. So in this case, the installer was actually independent from the manufacturer. And that's definitely something that we can kind of talk about later on, because that's definitely comes with benefits, but also with challenges. Next slide. But it all worked out well. It all came together. Everything fit. The groin bolt is on the bottom right there. That fit as well. And then also what's pretty good about this coordination piece is that you can really look at the sequencing, because in passive house sequencing is just so important, because on the bottom there, the image. So the membrane leaders had to be placed before the trusses came in. And once the trusses are there and you missed that part, there's no way that you can go back and redo that. So yeah, but it all worked out. Next slide. And this is also something really important to talk about, and happy to talk about that later on as well, which is the third-party review. Because as soon as you manufacture these closed panels, the project falls under the industrialized housing program here in Pennsylvania. And you have to fulfill a very rigorous third-party review process before and during production, and the factory also has to be certified. So that's, you know, if you're trying to make this approach more accessible, especially for smaller manufacturers and smaller projects, that's kind of a substantial hurdle. And I think it would be great to really kind of look at this. And yeah, talking about third-party review, that leads nicely to Angela, who is responsible for the FIAS quality assurance.
Thank you, Ilka. Okay, so yeah, transitioning to the verification piece of the project. My name is Angela Iraldi. I am both a CPHC and a verifier with Revision Architecture here in Philadelphia. I'm also the co-chair of the Passive House community in this area, along with Paul Thompson, who's on the line. So if you are interested in getting involved, please let us know. But like so many things in life, it would be fantastic, right, if we had a book to tell us all we need to know about Passive House verification. But unfortunately, that doesn't exist. And no matter how much you plan, issues are still going to happen. But that's okay. It's usually nothing we can't clean up. And we just need to be resilient, like the projects that we are trying to build, right? So in navigating this project, there have been a few unexpected things that came up, and I will walk through what those looked like. Next slide, Shannon. Okay, so first, it was most of the team's first time working on a FIAS project. With any new project, there's a learning curve, and with FIAS, there are some common oversights with respect to process milestones and requirements. Luckily, we were involved early in the project to review all of the requirements and expectations. And although there were a few items where the team was like, oh, I had no idea that was a thing, we were able to get them resolved early on so they didn't become larger issues down the road. But I can't stress enough that if it is your first time working on a FIAS project, please have an early review with your rater. We like to do at least a pre-mortem meeting and kickoff meeting with both the design and construction teams on the project. You know, and just a couple of things here. It's like, you know, for example, did you know that your HVAC contractor will need a specific certification if you have ducted heating and cooling systems, or that your domestic hot water systems will be tested? If you didn't know these things and you're working on a FIAS project, please go talk to your rater. Next slide. Secondly, as with lots of projects, field changes happen, but it is the job of the rater to verify what is installed is per the design. For example, one of the first things we observed on this project was we had at our subslab inspection, 6 inches of subslab insulation installed, but the drawings called for 4 inches. So in coordinating with the team, it was confirmed that there was a design change and the installed condition was supposed to be 6 inches, but we needed to also verify that the WUFI model accounted for this change. And in our case, the model wasn't really affected with 4 inches versus 6 inches. But if you're working on a larger multifamily project, for example, you know, 2 inches of extra insulation could really mess with your cooling loads. So it is something to be aware of. Next slide. And then finally, moving on to our experiences with our preliminary blower door test. So at our first blower door, we found kind of your typical issues, right? Leakage around gaskets and ERV penetrations, but we also ran into issues with our ceiling air barrier installation. So for this project, we're using a sheet applied SIGA air barrier, and it was adhered to the structure with staples, which is a manufacturer's approved method. However, as you can see in the photo on the screen, several staples actually missed the structural members, resulting in like all these tiny little leakage points across the entire ceiling membrane. And you know, how much this contributed to the overall total leakage is kind of hard to say, but it certainly did not help. The other thing I want to note here is that while it's obviously important to find all of the potential air leakage issues, it's also important to try to preclude issues as much as possible. So above this air barrier, we were installing loose fill insulation. And that lower right-hand photo shows this, but SIGA actually recommends installing battens to support the load of the insulation so that the air barrier doesn't pull away from the structure and, you know, completely lose its function. So that was something that we noted as missing in this vaulted area of the project, and the battens were subsequently installed. So with all these issues found and our initial test results in, we failed. Next slide, Shannon. But that's okay, because we kept going and we kept trying. We went back and taped over all of the staple holes throughout our air barrier. We did IR scans to identify leakage points, especially in areas we couldn't directly access, right? And we involved the team. I mean, when you're dealing with passive house airflows, leak chasing can become this like brain teaser of a treasure hunt, right? Like it could be so difficult, but it's so satisfying when you do find these issues. So second time around, we patched up as much as we could, and we failed again. Next slide, but that's okay because we tried again. So the third time around, we're really looking at some of the smaller details, right? Like what is left for us to get. So we went back with more tape on our ceiling air barrier. We also applied a liquid mastic over the tape adhering the subslab vapor barrier to the ICFs on the lower level, as Shannon mentioned earlier, because those ICFs actually have like these tiny little ribs that are like pathways for small amounts of air to get through. So we sealed all that up. And the third time's the charm, I guess, because we finally passed our test with those things. And I will say it's nice that it took us a few tries, because it would have been super boring and uninformative if we passed the first time. So last slide, Shannon. So at this point, we feel like we are really set up for success for our final testing and inspections. And we are excited to deliver, hopefully, a very successful project come this summer. So thanks everyone for joining and listening to our presentation. And I think I'll throw it back to the Passive House Accelerator folks.
Thank you, ladies. That was fantastic. Really appreciate all of your perspectives. What a great team. So we're going to kick it off with some general questions first, and then we'll roll into the after hour. And thank you all for agreeing to stick around. I think we're going to have a lot of fun.
Yeah, lots of questions here. Lindsay Klein, you are first.
Oh my goodness, sorry. Can you hear me?
Yeah.
Sorry about
yes,
that. You caught me trying to
It happens. It's my job.
Sean, just remind me, I know I asked two questions.
Yes, you did. The first one, let me scroll up, sorry, is are you planning to have an electric generator?
Yes, that's right.
Another one was, won't the wood fireplace overheat the interiors? So good questions.
Great questions. Thank you, Lindsay. Those are awesome. So the first one, an electric generator, we're going to do a small battery just to cover refrigerators and outages and charging phones, because sometimes we have like 9-day power outages in Pennsylvania. And for the future, we're going to replace the roof with a Tesla roof when it's available, so that the homeowner doesn't have to see the solar panels from the cathedral side or from the street side. She would have put them in the yard if there was a place to hide them. There is a small place on the roof to hide them where we actually put conduit up to the roof, but we don't know if we'll need those for this small battery that we're going to do now. Hopefully, when she moves in, it will be fully generated power from on-site sources. And for the second question,
Fireplace.
Fireplace, great question. So it's got a direct air intake and it's fully airtight. So it will radiate, right? And it is very efficient. It's like, I think it's 85 to 90% efficient because it has a number of chambers in it. But it might, and they might end up building a fire and opening the windows. But the other good news is in the interim, when there are tenants in there for the first 20 years, if the power goes out and they light a fire, they're going to keep that whole house warm with one log. So it's the good news. That the owner, Susan, is very much a wood burning fireplace girl, and so am I. And so her opinion is a house has no soul without a fireplace. So the only thing is I would like to have put in a different unit. But thank you for your question. Did that answer your question?
It did. I think it's a big struggle. Both of those issues are really big for all of us right now.
Thank you.
Good point, Lindsay. And we're over to Steve Glickman.
Sorry, I missed the very beginning, but I thought I heard you say when I did walk in that this was a multi-tenant house. And if that's the case, was it an uphill battle at zoning, or was that allowed?
Well, the original, and thank you, Stephen, that's a great question. The original home that we had to take down, we tried to reuse it. We had lots of options to try. I'm a saver, so I try to save everything. But there were rental units in there. And so the zoning, at one point there were more than 2, but what we did was we just lobbied for the 2 that she wanted, and the township was perfectly fine with that because they know that she's going to rent it to families. And there's really a shortage of housing, rental housing in Bernathen for families. So
great.
Thanks,
Stephen. And we're going to go to Susan. You have a couple.
No,
and
just
then,
one.
Okay.
Fine. Yeah, thanks. It really, I was curious about well, maybe it's 2. Okay, the numbers that you got for your, you failed and your air tightness test. That's number 1. And then it was just, maybe you said it and I might have missed it. Sorry, lots of info about the square footage, because I was curious about also the air tightness test, like what the kind of the ratio. I think Hans asked something about that, the size, the area to volume ratio. Just curious.
Well, the house is about 2,000 square feet in the carriage side and under about 4,500 in the main house. And then the event space, which is going to be unfinished for the first 20 years, and the garage make up the rest. And it's about 10 total for the entire structure.
10,000 square feet. And that's what you were testing?
No, we didn't include the garage. I'm sorry, I don't have the condition floor
okay
for you off the top of my head.
And then do you remember the numbers, the air tightness?
Yeah, I can chime in there, Susan.
Like,
sorry, I was having technical difficulties. Of course, like during the worst time ever, my computer just like froze. So I'm so sorry if I missed other questions.
No, you're right on time.
Okay, Susan, yes, I can answer your question. So first blower door test, we were at 0.83 or 0.083 CFM per square foot of enclosure area. And just remember, this is a FIAS project, so it's based on that enclosure area. And then second blower door test, we were at 0.063. So we were like just over that 0.06 benchmark. So we were really close. And then with our third blower door, we were at 0.052.
And there was maybe, I don't know, Sean, do you remember what, I think Kevin talked about this last time in terms of how FIAS does their air tightness measurements compared to how PHI does their air tightness measurements, and does the volume, can you play around? I got a little bit lost last time there was that conversation going on. Who wants to jump on that one?
Shannon, do you want to do it?
Well,
Yeah,
actually, Angela, you had put in the chat. So I was on last night too, Susan. So thank you for bringing this up because I have the same question. Kevin put in the chat, or someone put in the chat, if there was a way to translate between the measurements that FIAS uses and PHI.
Oh, sure. Yeah. I know. I forget the equation off the top of my head, but so basically, FIAS uses a air leakage per square foot of the surface area of the project, right? Whereas PHI uses air changes per hour. And that's kind of based on the volume of the project. So it's like how often you're totally exchanging the amount of air that's in that space. You know, that was one of the changes that kind of came out of FIAS's evolution, I guess. So initially they were using an ACH based air leakage requirement, but they did transition into this enclosure area based air leakage requirement, because when we're looking at air changes per hour, it really doesn't scale necessarily appropriately based on volume. Right? So you might have a low air changes per hour number in like a large building, but that still could be a lot of air leakage, right? So when you use a metric like per square footage of enclosure area, you kind of even the playing field with the air leakage there, and it's not so dependent on the volume or like the scale of your building.
Mm-hmm.
Does that answer your
question? Yeah. I'm getting a better grasp for it, and I see the chat is sort of going on. We might have some, yeah. Okay. Thank you very much.
I'm like, I don't know what's going on in the aside, so I'm like, I can provide more info, but
no, it's all good. Even Kevin chimed in there too. So
Angela, maybe you want to add too that the last blower door test that was passed was actually after installing the ceiling insulation, right?
That's a good point. Yeah. So, you know, I think we noted in our presentation, we had our air barrier on the ceiling that had a lot of leaky points because of the staples. But we did have that loose fill insulation get installed after that. So good point, Ilka. Like our third and final blower door test did have that insulation installed, which helped. Right? Because, you know, we obviously lay in that insulation, and that in itself is kind of patching up those holes as well. So
let's see. Let me see if this is the right screen this time. Yes, it is. Everything we do at the Accelerator comes thanks to the support of our sponsors. So I want to thank them very profusely. So our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are BR+A Consulting Engineers, Brennan Insulation and Airtightness, Inotech Windows and Doors, and US Engineered Wood, T-Stud.
Thanks, Zach. All right, well, here we are at 8 o'clock. The hour flies by so fast. Well, there's nothing left to say except for let's go into the after hour.